everyone. In this video, I'd like to talk about properties of logarithms. So as a general equation involving a logarithm, we have y equals log base b of x. So the way I would read this in English is log base b of x. So what I'm talking about is really a relationship between my variables y and x. So y, this is my exponent. B is the base. And x is what you get as your answer, so to speak. So in other words, if I gave you the expression y equals log base b of x, that's equivalent, so I'll say it's equivalent to writing b is my base to some exponent y equals x. Here's an example. Suppose I gave you something like y equals log base 10 of 100. Well, that's equivalent to saying 10 is my base, y is my exponent that I'm looking to find, and 100 is the answer I should get when I set this up. So if I'm thinking about what exponent will work, well, y equals 2 would be my answer. In other words, log base 10 of 100 is equal to 2. Now, when you're working with log base 10, it's so common that people will often not even write the 10. So log base 10 is often written as log. So they often don't write the little subscript there to denote the base. All right, let's take a look at another example. Suppose I asked you y equals log base 7 of 49. Well, that would be the same as saying, hey, 7 is my base, y is my exponent, and 49 is what I should get as my answer. Same thing here, y equals 2. All right, let's make it a little bit more challenging. So suppose I gave you the example y equals log of 0.1. Well, that's equivalent to saying 10 is my base because they didn't write it there. So that's 10 to some power equals 0.1 or 1/10. And if you go back to think about negative exponents, you'll see, oh, yep, my exponent here needed to be a -1. So the answer here is y equals -1. Now, another common piece of notation that you'll see refers to the natural log. So let's take a look at a few examples with that. So sometimes you'll see something like y equals the natural log of e. And this refers to the natural log. E is the irrational number, and it's about 2.71. It's, like pi is about 3.14, and it has a bunch of digits that never repeat and never terminate. It's irrational. Same is true with E. This is an irrational number, and it's about 2.71. So when you see this ln, that refers to the natural log, and what that means is it's a log base e. They don't write the log base e, they just use the shorthand ln. So log base e, same idea. How would we figure this out? Well, this is equivalent to asking e is my base to some exponent equals my answer. Well, it better be true that y equals 1. So there are four important properties to know. And the first one is the change of base formula. So the change of base formula says that if you have log base b of x, you can change the base. Instead of having base b, you could change this to be log of base a. And I'll write that in a different color just to emphasize that we are changing to a different base. So the change of base formula says log base b of x equals log base a of x, all divided by log base a of b. And you might be wondering, why would I ever want to do this? Well, let me give you an example of how this might be really helpful. So suppose I gave you the example log base 0.001 of 100. Well, to use the change of base formula, I'm going to go through here. And I've got log of 100 in the top. I'm going to change my base to log base 10. You could change it to log base 7 if you want. But I'm going to change to log base 10 because I know right off the top of my head that log base 10 of 100 is 2. We already did that problem earlier in the class. Now, down in the denominator, I will have log base 10 of 0.001. And if I go over into a dark corner and say, hey, y equals log base 10 of 0.001, what is that? Well, 10 is my base, y is my exponent, and I'm supposed to get 0.001. And if you count, we moved over 1, 2, 3 decimal places, so y equals -3. Final answer there, using the change of base formula, would be -2/3. The next important property, and we've got 4 in total, the next one we're going to look at is something called the product rule. And as the name implies, the product rule has to do with multiplication. So if you had log base b of m times n, you can split that product apart and say it's log base b of m plus log base b of n. And where is this coming from? Well, this is coming from exactly our properties of exponents. If you recall, something like 2 to the x times 2 to the y, same base, different exponents, we added our exponents. And so if you did a log of this on both sides, if you did log base 2 on both sides, you derive exactly our product rule for logarithms. I won't go into the proof here, but if you're interested in that, feel free to contact me. For now, we'll just state the product rule, and let's do an example. Suppose I asked you to compute the following. Suppose I asked you log base 3 of 2x plus log base 3 of 4y. Well, you could combine that into a single logarithm via the product rule, right? So we have a log plus a log. That's exactly what we have here. We have a log plus a log. So I can combine that into one log base 3, and I'm going to multiply the arguments. So that's going to be 2x times a 4y, which is probably a lot better if we write log base 3 of 8xy. The quotient rule works in a very similar way. Keep in mind, I'm not worried about n being 0. N is not going to be 0 because I cannot even take log of 0. 0 is not in the domain of the log function. So I'm not worried about dividing by 0 there. And as a fourth property that you should be aware of, this is called the power rule. We'll write that down here. So the power rule says that if you have log base b of x to the k, that exponent of k you can pull down in front, so k times log base b of x. So here's an example of that. Suppose you had something like log of x plus log of x. Well, on one hand, you say I've got one banana and another banana. I have two bananas, or in this case, two log x's. On the other hand, you might tell me, oh, I'm going to use my product rule. And my product rule says if you're adding up a log plus another log, you can combine them and multiply the arguments, which is log of x squared. And indeed, log of x squared equals 2 log of x. These are equal to each other, and they are equal to each other by the power rule. So they're kind of all connected, all these properties. And you don't recommend memorizing them at this point. Just put them on a formula page, and if you use them over and over, they will become part of your working memory.